Today, we're diving into a really interesting concept for a metal spoon. And the material we have here claims it's not just a modification, but a fundamental change in geometry. The author even compares its potential impact to the introduction of the wheel in lure design.
And that's a heck of a claim. I mean, that comparison, it immediately raises the stakes, right? We're talking about a spoon with this new radical feature, a stabilizing element, or a wing, that relies completely on a very specific curve they're calling the critical bend angle. It feels like an attempt to engineer out the very unpredictability that a lot of us anglers rely on.
Exactly. And I think that's the core question we have to wrestle with here. Does this engineered stability and the unique action that comes from it, does it genuinely create a new superior tool for us? One that actually delivers on that promise of increased effectiveness? I'm going to argue that, yeah, it does. That optimized geometry fundamentally improves how consistent and effective it is.
See, I'm coming at it from the other side. I'm really questioning whether this hyper-reliance on precise geometry on one critical angle just sacrifices the simple rugged versatility we actually need on the water. I see a lure that's, frankly, too sensitive, too impractical, and it gives up the adaptability you get from simpler designs.
Well, my whole thesis here is really centered on control and consistency. I mean, the wing's primary job is to stabilize the spoon during the retrieve. And that right there solves a core problem with traditional spoons that, let's be honest, we all know: blowout.
Hold on, could you define blowout for us just in the context of this discussion? What are we talking about?
Of course, yeah. So blowout is what happens when a normal spoon, especially if you're retrieving it fast, or you're in a strong current, it just spins out, or it rises uncontrollably to the surface, and you lose your depth, you lose your action. This wing, in this design, it actively prevents that. It lets the lure work effectively, consistently, across a whole range of depths, no matter how fast you burn it.
Okay, that consistent depth profile, that is appealing. I'll give you that. The ability to fish fast without the lure surfacing, that's a genuine advantage.
But see, it's so much more than just the depth. That forced stabilization makes the lure constantly try to roll onto its edge. And in doing that, it creates these strong, irregular vibrations that supposedly fish can detect from a really long way off. So on a steady retrieve, which the material says is the best way to use it, you get this pronounced, powerful tail swinging motion. That reliability, no matter the speed or current, that's the unique advantage. It's engineered for maximum sonic attraction.
That sounds great in a controlled test tank. I'm sorry, I just don't buy that it's practical for a normal day out on the water. I mean, reliability doesn't mean anything if it disappears the second the lure gets knocked against a rock. The material itself says the bend angle is a critical factor. For anyone who hasn't seen this, that means the entire action of this lure depends on one single precise curve.
It's designed to be stable and predictable, though, not fragile.
But the proof of how sensitive it is right there in the text. It says, and I'm quoting, "incorrect adjustment can completely disrupt the lure's action." So if that's true, your so-called reliable performance is totally inconsistent the moment it's not factory perfect. You're basically building a precision instrument that needs special treatment just to work at all.
But the whole premise is that the precision is what's necessary to get that superior action. You can't get this unique, consistent roll without that exact geometry.
And yet, the author has to go on and talk about needing to modify the body bend, or the concave section, or the convex profile after the angle gets messed up. I mean, to me, that language just screams a lack of robustness. It makes fixing it in the field almost impossible for the average guy. So I have to ask the folks watching, would you trust this action on a week-long trip where your gear's getting bounced around in a boat? Or would you just stick to what you know? A simple spoon is forgiving. This one seems to demand special care.
Okay, but let's pivot to the action itself, because the stability is the key that unlocks the real performance here. The wing guarantees the action stays consistent, both on a horizontal retrieve, that steady tail swing, and also for vertical fishing. Vertically, you get a strong, really expressive flutter and rotation on the free fall. That guaranteed action across both styles of fishing is what they're calling revolutionary. It works for you, guaranteed.
I see why you'd value a guaranteed performance, but let me offer a different take on what's attractive to a fish. That stabilization, that rigid control over the dive and rise, that might actually be its biggest flaw. With a traditional spoon, so much of the action comes from the angler's input. You know, a sudden pop of the rod tip, a quick crank of the handle to create that aggressive, erratic action.
But why rely on an accident?
Because that chaos is what often mimics a distressed, fleeing baitfish, and that erratic, chaotic behavior is exactly what triggers a violent reaction strike. By rigidly stabilizing the lure, by preventing it from darting up or diving down, doesn't this design take away the angler's ability to create that chaos when you need it most? You're trading dynamic, angler-controlled variability for a kind of static, manufactured consistency.
I would strongly disagree with calling it static. The motion itself is very specific and powerfully irregular. It's got that constant roll, those strong irregular vibrations. That's sophisticated attraction. And besides, the material makes it clear that the stabilization lets the lure work at all depths efficiently. Your traditional spoon's dynamic variability just means a quick pull might lift it right out of the strike zone. This lure keeps the optimized action right where the fish are.
But you're limiting the entire spectrum of what a fish might react to. They don't just hit consistent vibrations, they often react violently to sudden, unpredictable changes. When a lure is stabilized like this, it sort of dampens the feedback between your rod and the lure. And this is where anglers really start to split, I think. Do you want a guaranteed, engineered action, or do you want angler-controlled chaos? What do you think? Would this guaranteed action work where you fish, or do you prefer to control the chaos yourself?
The guaranteed action works precisely because it's engineered to be detected. That unique acoustic signature, that constant roll and vibration, it maximizes the fish's ability to find the lure from a distance. That's always the first step. This design shifts the focus from, random triggering to maximized detection.
Okay, that sounds technically sound, but let's think about the average angler's environment. Let's say ice fishing vertically. That unique action is, again, 100% dependent on that bend angle being perfect. And they give us specific parameters, an original blank size of 42 by 17 millimeters, and a max recommended weight of only 5 grams for vertical fishing. I mean, that points to extremely tight tolerances.
But that tightness is a feature, not a bug.
It makes the lure practically disposable, though. If the weight and the geometry are that critical, how can the average angler who's dealing with cold temperatures, rough transport, accidental drops, how can they maintain this critical factor without specialized tools? It feels like this design puts a level of technical burden on you that most anglers just aren't going to put up with.
I'm not convinced by that, because you're focusing only on how vulnerable the object is, not on how effective it is when it's working. The whole goal is maximized attraction, and you get that by optimizing 2 completely different modes of action, the stable retrieve and the fluttering fall. The precision is just the mechanism that lets it switch between those 2 states cleanly and powerfully.
That argument just glosses over the fact that a complex system is always more likely to fail than a simple one in a rugged environment. If that bend angle is off by just a little bit, the entire premise of the lure, that specific roll, that unique vibration, it completely collapses. So now you've got a complex, dead piece of metal. A simple spoon, if it gets bent a little, it still has most of its original chaotic appeal.
But look at what the material says happens on the pause. That same sensitivity ensures the lure flutters and falls, rotating around its own axis. This deliberate, calculated instability on the pause, combined with the extreme stability on the retrieve, gives the angler 2 distinct, powerful methods. It offers precision, not just complexity for its own sake. It gives you a strong, expressive rotation that can pull fish in from a considerable distance.
And what's the lifespan of that precision? That highly specialized action is built in a lab, and I suspect it won't last a full season of heavy use on a boat. And that is a crucial, practical thought that, for me, outweighs a minor increase in its vibration pattern.
I'd argue the cost of not having that precision is leaving fish unhooked. This thing offers an optimized, dual-mode performance that standard spoons just can't deliver across both horizontal and vertical fishing at the same time.
All right, let's look at the final piece of this puzzle then, the hardware. The author specifically rejects using a split ring, period. They want a suspended fly or an assist hook with a direct connection, arguing it's simpler and avoids negative effects. But if we accept that the lure rotates aggressively on the fall, how does tying it on directly affect the fly?
That's an interesting point, but I'd frame it differently. The author is prioritizing the integrity of the lure's action above all else. They believe split rings just introduce unnecessary elements that could mess with that primary movement. Maybe it dampens the rotation or causes line twist.
But the whole purpose of an assist hook, especially one with a fly on it, is to provide a secondary, often independent bit of attraction, a little target, some color, some extra movement. If the lure is rotating violently, a direct connection forces the fly to rotate at the exact same rate. I'd argue that restricts its free movement, its natural flicker. It just becomes an extension of the spoon, not a separate chaotic element designed to trigger that final strike.
Well, if the body itself is providing that strong and expressive action, the fast rotation, the flutter, the vibrations, then the direct tie just ensures the assist hooks follows that action perfectly. You maximize the impact without watering it down with extra hardware. The author clearly sees simplicity here as maximizing effectiveness.
I still think the dynamic freedom you get from a split ring lets that assist hook lag or move a little bit out of phase with the lure body, and that's what gives it its triggering power. By forcing a direct connection, you're making everything move as one.
It limits the fly's ability to create its own independent flash during that critical fluttering phase.
The material clearly states, though, that practical use demonstrates that this approach can improve effectiveness. That suggests that the simplicity and the focus on the pure, undiluted movement of the metal outweighs any benefit of an independent hook. The geometry is the attractor, the hook just has to follow it and, secure the fish.
It's still a gamble on efficiency. Do you get rid of a potential variable, the split ring, at the cost of crucial dynamic freedom for your hook? I mean, have you ever seen a direct tied assist hook really make a difference compared to a standard split ring setup, especially when you're dealing with rotation? I'm still skeptical it's worth the trade-off.
So for me, the geometry, specifically that stabilizing wing, it achieves a consistent, wide-ranging depth, and it generates specific, unique actions that promise a higher degree of engindered control and attraction than our traditional designs. It's an evolution, and it's driven by pretty high technical standards.
My fundamental objection is still its practical vulnerability. For the experienced angler who's focused on durability and hands-on control, this design just seems to trade ruggedness and forgiveness for a highly specific and potentially very fragile performance. I just think that manufacturer complexity can't come at the cost of being robust.
Ultimately, this concept really does challenge our standard assumptions about what a metal spoon can do. It forces us to weigh this pursuit of engineered precision against the simplicity we need for practical, everyday fishing.
And that's a debate every angler has to have with their own tackle box, right? Choosing between complexity and reliability. There's definitely a lot more to explore here about what high precision geometry can really offer us.